Hi guys, in this video we're going to focus on multiplying our radicals. So we're multiplying radical expressions. This line aligns with our 8.3 notes, the first practice set on those 8.3 notes. So let's just start off easy. I've given you to simplify the square root of 16. 16 is one of our perfect squares. I know that 4 times 4 gives me 16. So therefore the square root of 16 simplifies to just the rational term 4. And that is a whole number. That's a counting number. It's our integer 4. That leads us to problem 2, where it says simplify the square root of 28. Now, at this point, if it's easier for you to list the perfect square factors, you're welcome to. You can list 1, 4, 9, 16, 25. All of those are lower than 28. But eventually, you guys will start simplifying these a little bit faster. So I know that 28 can be simplified to 4 times 7. And I know that the square root of 4 is 2, so this simplifies to 2 square roots of 7. Then we got square root of 20. Well, I know its perfect square factor is 4 again, so that's going to give me 4 times 5. Now I got the square root of 4 times square root of 5. And the square root of 4 is 2, so that's 2 square root of 5. That leads us to what we learned about today, or learned about in this 8.3, which was the multiplying of radicals. So when you multiply radical expressions, there are a few different ways that you could tackle this, especially with this problem number 4. What I do first is I check what I'm multiplying. So right now I'm multiplying the square root of 2 times the square root of 9. But notice with that square root of 9, it's a perfect square. So we could go ahead and simplify that. I know that 9 simplifies to 3. So I can say that this is a square root of 2 times 3, which can just be written with a coefficient of 3 times the square root of 2. But if you're not looking at it that way, you may say, well, I need to multiply my radicands. And that's fine too. So identify your radicands as 2 and 9. So that's going to give me the square root of 18. Then I know that the perfect square factor from 18 is 9. So that's 9 times 2. So that's the square root of 9 times the square root of 2, which will simplify to 3 times the square root of 2. So we get the same answer both ways. But if you are looking at this and you automatically see a perfect square inside the radical, go ahead and simplify it. Now for number 3, it says 6 times 2 times the square root of 12. First step is to multiply our like values. So in this case, that first term is just an integer, and it's a rational number, so I can say 6 times 2. So I'm multiplying the coefficient by the rational number, and I'm still going to have the square root of 12. 6 times 2 is going to give me 12, multiplied by the square root of 12. But then I've got to simplify that square root of 12 because it does have a perfect square factor of 4. So I've got 12 times the square root of 4 times 3. That's going to give me 12 times the square root of 4 times the square root of 3, which will simplify to 12 times 2 times the square root of 3. And 12 times 2 is 24 times the square root of 3. We're going to do something similar with number 4, but instead of multiplying our coefficients, we're now going to multiply our radicands because we only have a coefficient on that first term, so we got 3. And we're going to multiply our radicands, so everything underneath the radical symbol, so that's 3 times 12. And I know that 3 times 12 is 36, so that gives me 3. That simplifies to 3. Excuse me, guys. 3 times the square root of 36. And guys, 36 is a perfect square, which is going to give me 3 times 4. And that simplifies to the integer of 12. Going on to the next problems, I've got 2 times the square root of 3 multiplied by 4 square root of 8. So first thing I'm going to do is multiply my coefficients. My coefficients are 2 and 4. So I've got 2 times 4. And then in my radical, I've got the radicands, 3 times 8. I know that 2 times 4 is 8, and 3 times 8 is 24. I know that 4 is a perfect square factor of 24, so that can be broken down into 4 times 6 inside my radical. So my radical now becomes 4 times 6. And that's going to leave me with 8 times the square root of 4 times the square root of 6. And again, guys, if you can automatically see that, you don't have to write out all the steps. So that gives me 8 times 2 times the square root of 6, which is going to simplify to 16 times the square root of 6. And guys, we got one more for this practice set. For this practice set, we've got, or for this last problem, we've got 3 square root of 3 times 2 square root of 3. So we got to multiply our coefficients first. So that's going to be 3 times 2. And multiply by the square root of our radicands multiplied together, which in this case are 3 times 3. Notice those radicands are the same number. Anything multiplied by itself is a perfect square. So I know 3 times 2 is 6 times square root of 9. And 9, the square root of 9 simplifies to, you guessed it, 3. So that's going to be 6 times 3, which then simplifies to the whole number 18. Guys, I hope this helped you with multiplying radical expressions. In the next video, we're going to look at adding and subtracting our radical expressions. Thanks, guys.